I'm Jamie Vidic, Director of Educational Products and Services at the ISA. I am in the staff liaison position to the ISA Science and Research Committee. And this committee serves several purposes, one of which is elevating the importance of research within ISA, fostering exchange among the research community and professionals, identifying important new opportunities for science and research that add value to arboriculture and urban forestry. The committee also funds and selects literature reviews to be published in ISA's scientific journal, Arboriculture and Urban Forestry. The committee holds panels and webinars like this one, and nominates qualifying individuals for the ISA's L.C. Chadwick Award for Arboricultural Research. And you can see in the right panel, the current members of the ISA Science and Research Committee. Before I pass the mic over to the area president, I just want to cover CEUs. For those of you who are looking to get CEUs for this webinar, you will receive one CEU for whichever credential you hold. And for the board certified master arborist, that will be one science CEU. We should have all of your cert IDs, but if for any reason you did not provide your cert ID with registration, you can email that to eps@isaarbor.com. There will not be a CEU code associated with this webinar. Criteria for earning CEUs is that you attend the entire webinar, and your participation will show in the attendance report for this webinar, and we will assign CEUs based on that report. Please allow 4 to 6 weeks for CEUs to be uploaded to your CEU report. I guess that leaves any questions or concerns that you may have, you can send to eps@isaarbor.com, and the Educational Products and Services Department will address them. But I'm going to pass the mic now over to Dr. Andrew Hirons, President of the Board of Area.
Thanks, Jamie. That's really great. I just noted that a number of people are saying the chat's disabled, although we've obviously got the Q&A working. So perhaps Jamie or Sharika in the background, if you can double check the enabling of the chat, that'd be fantastic. Okay, so as Jamie said, I'm the current president of AREA, which is the Arboricultural Research and Education Academy. And some of you might know us, but if you don't, our vision is to foster an innovative and collaborative community where scientists, educators, practitioners, and students support each other in producing rigorous research on urban forests and putting that research into practice. And we do that in a number of different ways. We fund knowledge exchange events, and if you're interested in accessing that funding, then please do get in touch with us. We award student grants for the ISA annual conference, and so there will be students that are supported in attending that conference. And we also at the conference host a social, and this year we're hosting a social, or co-hosting a social, with the ISA Science and Research Committee. So that's a really exciting opportunity to come and meet our area colleagues, meet other people in education and research, and network for them. So please do look at that in your registration documents and registration requests when you're booking your place at the ISA annual conference. The area social will be an option on there. We also publish a regular newsletter with various opportunities and updates from researchers, conferences coming up that you might be interested in applying for, submitting abstract to, that sort of thing. And of course, we co-host a joint ISA SRC area webinar series. And this is in fact the first of those webinars. So it gives me great pleasure to welcome Kevin Martin to this webinar. And I should also say, I should point out that it's the board members of area are diverse and brilliant, and you know what we do couldn't be done without those board members. And again, they're in the right hand column there. Okay, so by way of introduction to Kevin, then Kevin is based at Royal Botanic Gardens, Kew. He's the head of tree collections there, and so he's got a lot of responsibility, not only for curating the tree collection as it is today, but everything that involves in terms of ensuring the legacy of such an important landscape, a really important landscape for all arborists, because they host Kews host so many important trees from a very wide range of environments and different collections over the last few hundred years. And so it's a really important site for trees in the UK, but also internationally. Kevin's currently pursuing a master's degree at Lancaster University, where he's focusing on species distribution modelling and future climate projections, and really engaging and embracing those data-driven approaches around tree selection strategies for the Botanic Garden community, of course, but also there's a great deal we can learn from that work about how we can select trees for urban environments as well. So I don't really want to take up too much more of Kevin's time, but suffice to say, I'm really personally very excited about this webinar. And yeah, very warm welcome to you, Kevin. I'm just going to stop sharing my screen now so you can share yours.
Thank you very much, Andrew, for the introduction. So let me just share my screen. There we go. So is that all clear for everyone? Is the screen okay? So yeah, as Andy introduced, this is a discussion about how we started using data to start looking at our landscape and the future of the Kew's landscape, which is going to be really significant as we move through the next few decades. So in order to start this, what we had to do first was to understand what we have and why we have it. So in order to do that, we started carrying out a really extensive audit of the living collections. Now, this hasn't been done since the 1970s. So we did a really big audit to understand why and what species diversity we have, but also really importantly, mapping the young trees. Again, this hasn't been done since the early 2000s, and it's really important as we move forward in understanding the landscape and how this is going to be affected through climate change. So this all leads in to a suite of documents. So we currently have our living collection strategy. So this is all part of that. But more importantly, over the last 18 months, we've been working on a succession plan document, which is going to be one of the most important documents that Kew has done for a very long time when we look at our living landscape. We've done lots of audits and we've done lots of really important documents in science, but we haven't done anything in the living landscape. So for us as an organization, this is extremely important work. And again, this will lead to an update of the living collection strategy after our findings. We found some really interesting results from this work, and hopefully this will then drive the future direction of the Arboretum, especially when we start looking at trees. So we all know with the urbanisation of most cities now, this is really driving up climates. Okay, so with the extension of people, more people are going to be living in urban environments, and up by 6 billion by the 2050s. Therefore, for this to happen, infrastructure will need to be advanced and need to progress, but that has a real bad consequence and results in climate change. So both, this is going to increase greenhouse gases emissions and also development of urban microclimates. And that's what makes Kew so interesting. When we start looking at an arboretum, there's not many arboretums that are right in the middle of an urban heat island. And that's what's been really interesting for us here at Kew, is to see and observe how trees and plants react under an urban heat island. And it's been a real interesting journey to understand this. But, in order to understand this, we needed to understand our climate. We're very fortunate at Kew that we have one of the Met Office, which is our weather site of our here at Kew. So the Met Office collects all our data, and that goes to all the national news. And you often see when Kew in the UK is the hottest place of the day or of the year, and that's for many reasons. So a lot of what we found now is where Kew sits within this big extensive urban heat island. When we start losing our vegetation through drought, so when the trees start to lose their leaves or we start to lose the grass because it's really hot. We've got really poor soils here at Kew, very sandy, shallow soils. Our grass dies very quickly. Now, we now know that as soon as we lose our grass and it goes brown, we get really big temperature rises really fast. And that's because that bait grass, because of our soil type and the visitor numbers compacting the soil then takes on the same properties as concrete. So it really dries up temperature really fast. So that's often why Kew is the hottest place of the year when we look at our weather records. So to understand the consequence of this, we started looking at our weather patterns. So to start with, we started looking at mean annual temperature. So really significant for us. In 2022, Kew had its first year where the baseline, so our mean annual temperature for the year, was over 10 degrees, and that had never happened before. And this will start to have lots of consequence when we start looking at the growing season of trees, especially. So, you know, we start to see extended autumns or late autumns or early springs, and we're just trying to understand how this will affect us as we go on. So what I then started doing was doing some modeling. So by using lots of environmental data, which we download and we can interpret, we then start looking at Kew's climate. So we can see here that Kew moves from the 10.8, and by the 2050s, we're going to be up to 12.8. And then scarily, by 2090, we're going to be at 14 degrees. And that's mean, okay? So it's mean annual temperature. So that will be very warm winters and autumns, which is really significant when we start looking at plant growth. So not just relying on the modeling data, we then started looking and interpreting the data from our weather station. Very difficult, it's a bit patchy in places. So it took a long time to get these data sets together. But as you can see from this graph, if we look at the pinks and purples, what we're tending to see is a longer period of high temperatures, okay? Rather than really big peaks, we're going to get longer. So September, October, November are going to become a lot, and December are going to become a lot warmer. And now we're starting to see the effects of that already. For this year, for instance, the oak trees, the English oak or Quercus robur, that didn't go into autumn until December. So that tree was still active when through evolution, by November, December, it would have lost its leaves and starts going into its dormancy period. So this is really going to have an effect on the tree's ability to store energy and to have the energy ready for the following spring. So to look at the patterns, we then did a bit of modeling to look at how this carries on. And as you can see, it carries on the same trends all the way through right up to 2080. But, you know, so these are the things we're now starting to understand and what we may have to manage for the tree collection as we move forward through the decades. So temperature is just one variable, and, you know, plants need water. So we started looking at precipitation. So interestingly, again, when we start looking at modeling data, we currently have 607 mil on average of precipitation here at Kew. So not a lot, you know, that's not a lot of rainfall. And we have really free draining soils. So the water retention is really reduced. And this is something we're starting to observe. And that's often why we lose our grass so quick, because the soil conditions go into the drought phase very fast. So then if we look at the modeling, again, we don't see a significant increase. And that's what's alarming when we start looking at plant growth. It's okay to have an increase in temperature, but that increase in temperature is going to increase the water demand. So as you can see here, this isn't going to happen within nature on projected climates. We have a very, very little increase in precipitation. So, you know, that's one story. But what, as we all know, it's all about seasons. So we then started looking at what happens when we look at the seasons. Okay, so this again, this is current data. So this is from the 1980s up to 2020. And we can see here, we've got a big trend where we're having a drier spring. That's really significant. You know, when the trees are at their most stressed, they're putting all the building blocks in to go into bud burst. You know, we have limited water resources in our soils. So this is really significant. And again, our summer rainfall, we start to see a bit of a downward trend. But interestingly, we've started to see these increases in our winter and autumn. And that's going to be significant because we're then starting to get flooding and we're going to get waterlogged soils when the trees don't need that water. So that's going to start having adverse effects in the root systems and start causing anaerobic soil conditions. So again, this is all part of the puzzle to try to understand when we start selecting trees for the future. And again, when we can then move through, we've done a bit of modeling and we can see we have an increase a bit in spring rainfall, which is good to see. But again, we're going to get very wet winters and very warm and wet winters, the same as autumn, a bit like this year. This year, especially in the southeast of England, we've had a very warm and wet winter. So this is going to become more of a trend as we move through the phases and we start to see the impacts of climate change. And as you can see, again, we have very small amount of summer rainfall. And again, this is going to become really significant when we start managing the landscape of Kew as we move through. So after looking at the annual precipitation levels, we can see, again, that's not moving too fast. So, the reality is we're going to be in this really harsh, dry environment. This is an image that was taken in 2022. You can see the really vast difference between the southeast and the northwest of the UK. You can start seeing it here. You can see a clear green band. And actually, I witnessed this myself. So I was actually left London at this time, late July in 2022, to go to my brother's wedding in the northwest of Scotland, and we drove through and we left Kew at 40 degrees heat all the way through, drove up through the country, and you can see as we went further north it started to get greener and damper until we get to Scotland, which wasn't very sunny. It was 12 degrees and pouring with rain. So they're the sort of things we got to get used to, that we're going to have this very split environment from the southeast to the northwest. And these are things we've got to start to prepare for when we start looking at the landscape. But this has real big consequence when we start looking at living collections. So when we went through this big heat wave, we started seeing some really significant losses of trees throughout the landscape. So much so, by the end of this heat and drought wave, heat wave and drought, we lost up to 460 trees. A lot of them were small trees, they weren't all mature trees, but you can see here some of them were very significant. And this is an alarming thing to see in a landscape when you're a botanical garden. And this is us trying to manage it. So we're doing a lot of soil work to try and manage the soil so we can try and hold and lock in as much water as we can for the trees to have that availability of water. But we just couldn't do enough, and we couldn't irrigate enough to try and keep these plants alive. And to give you an idea, as an arboretum and garden, we tried our hardest, and our water bill for July of 2022 was £80,000. So that's a significant amount of costs, and we soon realised that this form of management isn't sustainable. So in order to look at a sustainable way forward, we started the succession plan. As you can see, this is Kew when we lose our grass, and this is exactly what I was talking about at the beginning. All that lost grass there is then taken on the properties of concrete, so it's absorbing heat all day and then radiates at night, and that's where the stresses come in for us when we start looking at the landscape. And as you can see, my son living on site, my son was very lucky that when the gardens had closed, he had gone round on his bike. But this is one of the best images that we have to how barren it really did get. So what we wanted to do is start to look at ways how we could understand how we could start selecting trees by using this climatic data. So to start with, what we did is we started using the climate tool from the BGCI, which is a great tool. It's very interactive. You just put in the garden name or your longitude and latitude, you select your plants, and it gives you a result. So we thought, oh yeah, great. This is amazing. So we can go through our whole collection and we can then start risk assessing it. So when we started doing this work, you can see here, this is Quercus robur, and yeah, the predictions are that it's going to be on the edge of its range by 2090. So this is under what we would call a worst case scenario model. So this is under an SSP3 model. So, this is what we started to observe. But interestingly, this model only works on one variable. Okay, so within that risk matrix, it only uses mean annual temperature. Now, we all know, being tree and plant people, that it's not just heat that affects trees and causes stress, it's also drought and it's also water. And that's what this model doesn't take into consideration. So as Andy introduced, I am doing my research masters at Lancaster University. And, you know, I really wanted to understand how this works and the consequence of this. So I started using this model, but I soon realized that the model predictions of trees, which it was saying we could grow, I was watching die in the landscape. Okay, so some of the Northophagus, so we lost a lot of Northophagus menzesii, which this model was predicting should grow really well at Kew in 2090. It would if we just used mean annual temperature. But what was happening was the tree was really struggling for water. And when you started reading up on the tree and in its natural ecosystem in New Zealand, it lives in a valley and it has a lot of rain, okay, a lot of precipitation. So that would have nearly 1,500 mil precipitation a year. Well, at Kew, it only has 600. So for a mature tree, it was already on the edge and very, very it was struggling. So because of that, that heat just tipped it over, and unfortunately we lost all 6 of that species out of our collection. So this was quite alarming. So in order to get better predictions from using data and using modeling, I set about trying to understand what variables really do affect Kew and what ones would be good to look at and observe. So I started looking through. So to do this, I used all the variables. There was 30 variables used, and then I was just looking for the top 10 most important variables when we look at Kew's climate. So this is done under future climate projections, and we look at all the way through from 2020 to 2090. And this was to understand, if we start to build a model, what variables we need to look at. Okay, so we can see from here that they're various dots, but we've got 3 closely dotted together. So we have bio 9 and bio 8. So to give you an idea, for those that aren't familiar with the bioclims, bio 8 is the wettest quarter. Okay, so that's the wettest quarter of the year. So that's in the that's that data point. And then bio 9 is the driest quarter, so the driest of that year. So you know, you start to understand what's going on. And then bio 12 is annual precipitation. Now, really interesting, when you start building models, you don't want variables really closely together. So there's no point using bio 9, bio 8 and bio 12 because they're too closely related. They're also looking at the same data. But really interestingly, we have PET, seasonality. Now that's potential evapotranspiration. Now that's really interesting. So that's how much water is lost from the soil through plant growth. So that's really significant. So through doing a lot of research, I then started looking at other variables that we could use. So I then found this. So this is a really interesting variable used. So this is the climatic moisture index. So this is an indicator of drought calculated as the difference between the annual precipitation and the potential evapotranspiration. So the potential loss of water from the landscape covered by vegetation. Now that's what we're dealing with, aren't we? We're dealing with trees, we're dealing with vegetation. So, you know, that seems a better variable to use than just mean annual temperature. So this is the calculation. It's a very old calculation. Okay, so it's originally used in agriculture to start looking at crops. And, you know, it was a measure of the precipitation and effectiveness for plant growth that takes into consideration the weight of influence of water surplus and the deficit as related to water need. Now, this is what we're looking at. Okay, this is what we're trying to understand at Kew. So this is the old calculation. It has been modified, and in the model that I created, I used a modified calculation where there's a little bit of adjustment, especially when we look at classification of ecosystems. But this is really substantial, very used widely in agriculture and agroforestry. It hasn't been used in amenity plants. So this was really significant find when we started looking at modeling. So just to give you a bit of a visual, this is what we're looking at, okay? So we're looking at how much rain comes in and then the influence of plant growth, okay? And how much water that's pulling from the soil. And this is one of the best images I could find. It's very heavily vegetated. We've got nice green grass, which is no doubt irrigated. And then you've got all that pull from the soil, from all those plants respirating, and through their natural process of photosynthesis, it's all pulling from the water resources within the soil. So what I then set about doing was building my own model. Now, never intended to do this. This was a very steep learning curve for myself. I did a lot of research and a lot of reading in species distribution modeling. Now, that wasn't just for plants. I also did read a lot of papers around mammals and birds and insects, because they all use the same methodology, but for different factors. So that's when I started trying to think of the best way possible to start building the model. So this is a bit of a snapshot of the code. So the model's all written in R in RStudio, and it's an amazing tool which allows us to use massive data and get a story or find a solution from it. And that's what I started to use to build this model. So in order to build this model, you need very good data sets. I was very luckily put in contact with Kendit. So by talking to Kendit, he's done lots of modeling for agroforestry in Ethiopia. So fantastic guy to chat to, and he gave me some pointers on where to go. But he'd been creating these global databases, which are the basis of my model. But what I had to do also, in order to make sure it's relevant for the Arborita and Botanic Gardens, but also the urban environment, I had to build an urban database. So I also built my own urban tree database using the same variables and methodology as what Kendit did to build these two. So what we have here, we have tree goer. Again, these are all natural distributions, okay? So it's every wild point of that tree that's been observed in research and upload to GBIF. We then run that through lots of environmental packages, and we can gain all that data. So we now know the natural range of that tree and the climatic conditions it grows in. And then the same with city goer. Again, that's cities all around the world. So we've got over 52,000 cities in there with their future climate as well. And this just helps us to start building the models. So then we go on to the model. So this took some working out and trying to understand the best way to produce the results by using the statistics and everything. So it's fine having a statistical result, but it needs a word, it needs a meaning, and that, then I had to work that out. So in the end, through talking to Kendit, he very kindly popped into Kew when he was visiting the UK. We come up with this formulation. So when we're looking at tree species that aren't going to be able to survive their future climate, especially in the landscape, we call them outsider range. Okay, so the future climate is outside that tree or that plant's natural range. So if you would like to represent that within the landscape, you then have to put in a management in place. So that could be regular irrigating, or it could be for us here at Kew would be to put that tree under a glass house. So they're the things we start looking at. And then we start looking at endemic. So this is a very narrow zone, okay? And this is just where this tree or plant has a very limited geographical range, and it's unique to that zone. So if the climatic conditions change more than the predicted, that tree is going to be at risk. And then we look at the upper limits, okay? So this zone represents the maximum extent of the species distribution, okay? And again, this is when it's right on the edge of its range and it's really going to be pushing it, okay? So we're getting to the very upper limits of its ability to survive. And then the lower limit is where the species barely survives in that zone, okay? So for us here at Kew, that's a lot of the collection from Sichuan, okay? Sichuan province in China, it's very wet, it's very humid, and that's what we're not at Kew. Okay, we've got a very dry landscape and a very dry atmosphere. We don't have that humidity. So a lot of the plants that we're from running these models, a lot of the plant species that we have from Sichuan are all in the lower limits. So, you know, it's going to struggle. And we have to take that into consideration when we're looking at our landscape. And then the other, the zone which is within the wider 90 distribution, they're perfect. They're within range. They're the trees we're looking at. They're the future trees that we know through predicted climatic conditions and the modeling, they're going to do the best. Okay. They're the ones that we're looking at as our future trees. Okay. Our future landscape trees. They're the ones that should be able to deal with the future climate without too much intensive care. We could look at it. So they're the ones we're really looking at. So then these are the model results. So my master's thesis is on Tilia. That's why you got the Tilia results, because they're the ones I just had when I was building the presentation. But we have done the whole of Kew and we're working through it now. So as you can see the results and what it looks like when you get the model print now from your species. So really interestingly, that's one way of looking at it and one way to understand everything. We then wanted to start looking at other scenarios and understanding what happens at Kew. So what we had to start with is really understand, when we look at climatic moisture index, how much is it changing and how fast, in order to drive those results. And as you can see here, we have a really steep increase from 2020 to 2090. Yes, there's a big increase from 1981 to 2020, and that's to do with not only mean annual temperature, but the precipitation shift. But what we do see is a really sharp increase when we look at 2090 values, and that's mainly because of the increase in mean annual temperature. And precipitation doesn't keep in line, so we still carry on with the same precipitation values. So we want to understand what consequence this has to the living collections. So if you was to look at this graph, you think, oh, you know, it's not that bad, but this is just the number of species. Okay, this isn't the number of species we have within the collection. This is just the number of species that we have. So if we look here, we still have just under 500 species that are going to be outside the range, and then we got some in the upper limits. Within the wider range, we've done collections in the Mediterranean, South Africa, Southern Australia. So those species, you know, they're going to do fine. So for instance, things like holm oak, Quercus ilex, okay, that's going to do really well. We have a large landscape feature here at Kew called Sarn Vista, and that's all made up of Quercus ilex. So we know as a landscape feature that is, you know, that's future proofed. Okay, we don't have to worry about that. But it's other parts of the landscape we're going to have to start to understand. So as I say, in order to understand this, we started doing some detailed work. So from doing this, we then started to look at Kew's most, you know, 30 most numerous taxa within the living collection, and starting to try to understand how these results will affect our landscape. Okay, so as you can see here, there's a bit of movement here, and you know, quite a few trees are going to be on the edge of their range in the 2090 conditions, and that's what we have to understand. So again, this is why the mapping of the collection was so important, because we managed to build in some visualization. So if we look here, this is the effect on the Kew landscape. Okay, this is under worst case model for 2090, and this is the real significance it will have on the living collection. You can see there's a number of yellow dots, so they're the interesting trees. They're the ones we've got to do a lot of research to understand the significance of them being on the edge of the range, and see if the tree has a natural trait. So if the tree, you know, if it has a natural trait, it won't be a yellow, it would go into green because it has natural traits to deal with that stress. But until we know that, we have to categorize them as on the edge of the range. The red crosses, unfortunately, they're the poor trees that we're going to really struggle to represent. Now, in the southwest corner, you'll see there's not many dots, and that's partly because that's the conservation area. We're still carrying out a lot of mapping in that area. So once all the mapping is done and we've got those GPS points, we can then start to build up the picture and the significant loss in there. But it's mainly native species, or what we class in the UK as native species. So there will be quite a significant amount of yellow dots in that area, unfortunately. So, you know, this is the real consequence that we're starting to see. And if you look in the center of the screen, you can see there's some dots in the temperate house, and that's because there's some plants that grow in the temperate house that we're going to be able to grow outside. So that's a really interesting find, and hopefully something we can look at starting to move some of those plants outside into the landscape. But also just right of that, you can see a big green dot, a clump of green all together, and that's, you know, that's the Mediterranean garden, and that's why that's green. So, and then you can see the big green runway which is running from sort of center of the screen up towards the River Thames, and that's Scion Vista. So there, you know, that's predominantly Quercus ilex, and that's what's really interesting when you start to observe it in the landscape, and this is the real effect. So, you know, we can see the consequence of this for the living collections. So then we want to go that one step further and really start to understand what's happening. So in order to do this, we started doing some really interesting species distribution modeling. So this again is for Quercus robur. So then I started mapping Quercus robur. Okay, so this is just a snapshot of 5,000 data points taken from GBIF, a wild occurrence, once it's been cleaned, a wild occurrence of Quercus robur, okay, the English oak or the common oak of Europe, depending on what you want to call it. And then you can see there's a very little movement in Kew's climate between 1981 and 2020 when we look at Quercus robur as a distribution. But what's alarming is how quick 2090 moves, okay? So currently, in the 2020s, we're in the center of the distribution range of Quercus robur. But by 2090, we start really moving significantly out to an outlier. So what I wanted to do was understand how I could identify the area where that lives. You know, what ecosystem is that? Where is Quercus robur surviving where it would be suitable to Kew's 2090 climate? So in order to do that, what we started doing is using this formula. Again, this was after long discussions with Kendit, and he had built something very similar for Ethiopia. So he just said about looking into this formula. So this is what we looked at. So Euclidean distance serves as a tool to assess the similarities of dissimilarities between data points representing the climate variables. So basically what we're doing is we use mathematics to decide and understand how 2 points are familiar. And by using this enables us to identify a data point which has the potential habitat to basically adapt to our future climate, and we're looking at populations. Okay, so for me it's really important. Part of my job is to look at wild source material. So for Kew, we need to keep introducing new genetic material in order to play our part as a botanic garden. And in the future botanic gardens, this is it. You know, you had the great plant hunters of the Victorian era. They were going out to find curiosities or to find plants that look pretty for people's gardens. Now what we're looking at as botanical institutes is looking for trees that are going to be able to survive and thrive in future climate scenarios and future ecosystems. So that's what we started doing, and this work helps us to identify suitable areas to look at plant collections by using data, so we can really nail it down really quickly rather than guessing and trying to guess where we're going. And this is what's been the big advance for us as we move forward. So to do this, again, doing these dot plots, I've managed to work out the area. So by using all these latitude and longitude of these various species, we then could identify a suitable ecosystem that's matched to Kew's future ecosystem. So if we look to the right of this slide, that's the warmer and drier end of the species. Then if we look to the the left-hand side, as I look at it, is the cooler and wetter distribution of the species. Now you can see all the species there. So we use Celtis australis, which really is very suited to Kew. And then we've got Quercus castanifolia, Parotia persica, Tilia cordata, Tilia platyphilus, and Zelkova carpinifolia. Now they are really interesting plants, okay? So they exist in a really niche ecosystem, okay? The hurricane forests of Iran, and that actually drops down into Azerbaijan. And really interestingly, that's the only area where Parotia persica occurs in the wild. So this data starts to match in, and we start to understand how the landscape of Kew has been affected, and how and where we need to look to new ecosystems to collect new material. So after doing this work, we can then start to identify areas, okay? So this is the hurricane forest of Iran into Azerbaijan. And as you know, it's 55,000 square kilometers near the shores of Caspian Sea in Iran and Azerbaijan. And, you know, it's named after its ancient region, but it's really interesting because what happens here is in a rain shadow. So it's on the rain shadow, the Caspian Sea there, and that's what causes this really interesting environment where it's really dry. It has approximately 500 mil precipitation, and it has temperatures to 40 degrees, and it gets really hot. The soil is sandy, it's steppe environment, so sandy, free draining soil. And that becomes really interesting for me when I start looking at the Kew landscape. It's so similar. And that's what I found by using climatic moisture index. We can identify these areas, and it just saves a lot of hard work if we can do a lot of the research using data, and then we can spend our time in the field being very specific on the ecosystems and the environments we need to look at. So again, it's got a massive diversity of plants, and some of these, Quercus castanifolia, one of the oaks from that ecosystem, Kew's most successful tree. This is Kew's largest tree via volume. This tree is 39 meters tall, 38 in canopy spread. It's the largest tree in cultivation of this species in Europe. So it really enjoys life at Kew, and it's been so successful. And this tree in particular is what set me down the path of a research. So I used to be a tree surgeon, climbing arborist. That's all I ever wanted to do, was just climb trees. But when I started my career here at Kew back in 2012, I wanted to understand why this tree grew so well. And it was what led me into reading and understanding about ecosystems and the natural distribution of plants. And this tree is the one that ignited that in me. And that's why this is my favorite tree in the Arboretum. And that's why, because it sent me down this very different path to what I ever intended. But then if we look at other ones, so we look at Parotia persica, again, grows magnificently here at Kew, really well suited, grows really big, really strong. We never really see it struggle. And this is why. It's because it's from that correct appropriate ecosystem, from a free draining soil and very warm temperatures. And that's what makes this work so interesting. And we can quantify it out in the Arboretum, because there you go, that's Zelkova carpinifolia. Again, this is what we would call a troby. So that's one of the largest of the species in the UK. And this tree again was an early planting, 1750, this one, and it's still growing today, and it thrives in that environment. So that's what's amazing, and that's why Kew is such an important resource, because we can do this data, and then we can go and observe those trees in our living landscape, which is what makes it incredible. So then we start to look at mapping all the areas of the world where we can start to look at where we can go for future collections. So this is done through ArcGIS and through all our research results. And again, this just gives us a global view of areas we can then start to look at more specifically. So this is one of the visuals that's going to be in the living succession document, and these are the sort of resources now we're starting to build for all of horticulture when they start looking on going on expedition and plant collection trips for the living environment, so the landscape outside, that they can start using to identify suitable areas for collections. So the succession plan is in its final stages now. I really wanted to be able to show you some of the work from it, but unfortunately it's a bit behind by about 6 weeks in the creative stage. We've done all the boring data work. So hopefully by mid-May, we should have the succession plan document. So keep your eyes open. It's going to be widely published and it will be online in a PDF. So this is a lot of the work and how this is going to influence the management of our trees into the future. So what we wanted to do then is start to look at this and look at the results and start testing these model results. It's all right for me to say, yeah, the model works because I've created it. We then started to look at some of the results using different techniques. So one of the techniques we've been using is turgid loss point data that Andy's very renowned for doing. So this is methodology is what I've taken from helping Andrew out over the years on different research projects, and then you can start to see some of the matches. So if we look here, we can see Parotia persica. So the more I should explain, the more the negative the number, the more drought tolerant the tree is. So if we look here, we can see things like Parotia persica. That's really strong. Same with Tilia tomentosa. Interestingly, a steppe tree, comes from the steppe environment. Zelkova, carpinifolia, again, as we just seen, really strong. And then Tilia dilastyla, which is one of my favorite trees. Again, that's one of the limes from the Caucasus and grows through that bit of Iran in Azerbaijan. And hopefully this September, I'll get to see it in Georgia if we can find it. So that's really exciting stuff. So then what we're going to do for the future. So we've done all this work, but we don't want to stop there. We want to keep things moving and keep progressing. So I'm very fortunate in my position here. I've got lots of colleagues throughout science, and I work extensively with the head of research in the imaging labs. Now, Jehovah did a very interesting PhD, and this is his part of his postdoc. So what we started doing now is trying to understand how we can understand another trait. Okay, as I just showed you, we've seen how we can measure turgid loss point. So we know how strong leaves are. We know how they can deal with drought. That's only one question, okay, or one answer. What we want to understand is the other natural traits that trees have. So what we started to do now is start to look at the hydraulics, okay? So what we're now doing is starting to look at the vessels. So this is a big project that we're starting here at Kew this year. So what we're planning to do is we're taking small core samples from DBH and at the canopy center, so we can take and look at the vessels there. And then what we're doing, we're taking a meter branch from 3 different locations, so lower, mid, and upper canopy, and then we're going to section them down. So with the leaves, what we're going to do is xylem cavitation. So we will use basically a precipitating pump that will pump air through, and that's the best as we can imitate drought. And then from that, we can then build that in to how that tree deals with that stress. And then we're going to take wood samples and we're going to use 3D imaging in the labs to understand what those vessels look like. And the plan is to model the vessels of these trees from different ecosystems. So we can start to understand if they're adapting a vessel or adapting the anatomy of the wood in different ecosystems in order to survive. Because you've got to think, when we look at things like Tilia cordata, that will grow in the UK, but it also grows in Romania on the steppe, it grows in Georgia on the steppe, and it grows right up to Azerbaijan. So how can that tree grow in such varied ecosystems? It must have to adapt. So we're trying to understand how that tree adapts. And this is one of the methodologies that we're using to understand this. And finally, just before I finish, this is a really significant find. This is a tree I've wanted to see for over a decade. So this is a natural occurring hybrid. So this is a beech tree. So this is Fagus cross torica. This is very isolated pocket in Romania. The only other population known of this species is in Crimea. And I was very fortunate to go and collect it in September, and I now have some growing. I've got 100 growing actually in our Arboretum nursery. Now this is a really interesting plant. So this is a hybrid between Fagus savatica, so the common beech, and Fagus orientalis, the oriental beech. And this tree in particular is so drought tolerant. That environment, you can see it growing there. Again, that's in the steppe, so it's getting 40 degrees heat in the summer. It gets about 550 mil precipitation, and it's a real survivor, and it's surviving there. But what's amazing, that this just grows just in the valley. And as we went up through the valley and went to higher ground, you could see it stops, and there was a defined line, and that's because it just couldn't survive. It will only grow where it can survive. It can't set seed any higher up because it's just too dry and too hot. And what we then observed, you had a very defined line of where Fagus taurica grew, and then it went into another ecosystem, that's Tilia tomentosa. So that was really interesting, and it adds to the learning of how the ecosystems work, especially when you look at plant distributions and how these plant distribution models work when you go and see them in real life. And thank you for listening. It's been a pleasure to be the first one. I hope you've all found this interesting, and I hope you learned something from here. And if you've got any questions or anything else, there's my details at the end there. I will stop sharing.
Thank you very much, Kev. That was a really interesting insight into the complexity of what you've got to deal with in terms of maintaining a viable tree collection at Kew. I've got lots of questions. I'm going to sort of try and pick one or two from the audience. Carol King asked, I'm going to paraphrase this slightly, but I think the point of her question is, well, if we've got these populations of trees which are kind of good for our future climates, or your future climate at Kew, how long are they going to maintain a viable population in their current location? And in other words, how long have you got to, if you like, collect the material from these regions before those trees start being really pressured in their own regions? I mean, are they secure? So the Iranian forests. I mean, how long is Perosia persica going to be able to maintain its viability there? So I think that's another question.
Yeah, no, that's really interesting. It's something we've got to understand, and that's where we're starting to work with in-house partners. Because, I've been asked this question before. It's fine, selfishly, as a Westerner, so to speak, that I go there and I'm protecting the canopy cover for London and Kew and everything else by collecting seed from there. But what do they do? Where do they look for their next trees? And that's really interesting. Some of it may be through elevation. They can collect higher up the mountains in a drier ecosystem, and so on and so forth. But that's really interesting, and that's something we're trying to understand. It's very complex. The best one that I've learned recently is the Wollomine pine. Okay, so they've just found new genetic material of the Wollomine pine, and they've created a meta collection, and they spread it throughout the world in all different botanic gardens. And that's because it's threatened in its own environment. Okay, it's going to get drier, there's going to be more forest fires, and they know it's at risk. So they've moved it purposefully and spreaded it as far and wide as they can to protect it, to protect the genotype. And I think that's what we got to get a better understanding in botanical gardens and conservation, that it's not just through logging and things like that that's going to create a risk. It's climate. Okay, we're going to start to lose trees because of climate change and the rapid speed of it. So it's something we all need to work together and be collaborative with.
Yeah, and on that note of collaboration, Luana asked, there are lots of botanic gardens that don't really see trees as part of their collections. In other words, they're not accession plants. So what advice do you have for the gardens associated with climate change? I mean, there's going to be a lot of plants that aren't fully accessioned in a botanical garden network. I mean, are there opportunities to work together within, I don't know, ArbNet or within the Botanic Gardens conservation groups?
Yeah, of course. BGCI, that's a lot of their work, is to give you advice on, how to start managing living collection. The same with ArbNet. But what is important is people do start to realise the importance, even if it's just your native trees and they form the landscape, that we do start to accession and document them and map them, because it's going to become critical to understand the effect of climate change on plant growth. And that's something that we're still pushing for. We're still mapping all our collections. There's been a bit of a lapse through COVID and different difficulties for mapping, but we're now trying to get on top of that because we see how important it is. And if we're still trying to do it at Kew, I hate to think how little botanic gardens are going to cope. It's very expensive, but it's going to be so important as we move forward. And it's just about collecting that database and getting things accessioned.
Yeah, thanks. And Dave Slack sort of brings it closer to home and says, well, the local planning councils in the UK considering like incorporating this into their planting and maintenance plans? I mean, we probably both have a kind of a stake in this because being both engaged with kind of species selection guidance. But how much interest have you had from the local authorities?
Yeah, no, to be fair, I've had lots of engagement and they're really interested. It's going to be difficult because you will always get certain individuals that think we should only plant native species. We're dealing with an urban environment, which isn't, it's not a native environment. It's a lot warmer because of concrete and radiation and everything else. So it's really difficult, but we do need to start thinking about this seriously. We can model, and I've got lots of areas where native species grow. They won't be native seed, but they'll be native species. But yeah, it is something that I am pushing for. As Andy knows, I'm trying my damn hardest to get a big conference held at Kew on this subject with DEFRA and the planning authorities to really try to push this a lot higher up the agenda than what it currently is. There is a new urban tree document coming out that I reviewed this afternoon, which has been commissioned by the London Mayor and the Forestry Commission. So that will be published in the next month. And I just sent some review comments back today. But that's starting to touch on the subject. But there's a lot of work to be done.
Yeah, it's interesting. I mean, slight digression, really, but I mean, it's one thing, isn't it? Recognizing the species that we ought to be thinking about and targeting for, say, London or for New York or for Atlanta or, wherever it may be. It's another thing having that pipeline of trees available for the nursery industry, for the local authorities to be able to kind of invest in, buy, and plant into the landscapes, and that is a whole sort of different argument. I mean, I know people like Deb Hilbert's done work in this area and others as well, but understanding what it is in that pipeline of trees coming on stream, if you like, because it starts, doesn't it, with the work that you're doing in the gardens. But there's a long way then before it becomes a mainstream option in your local nursery or even in the national nursery potentially. So yeah, it's a very interesting and quite complex situation, really.
Yeah, we're looking at we're a bit behind the curve, to be honest, because it's going to take 10 to 15 years to get a tree into production after we've identified suitable ecosystem it should be selected from, all the species, all the trait that it has. So it's a long process. And this is the thing, we're dealing with trees. They're slow growing organisms. It's like we were discussing earlier. I've got lots of stuff growing in the nursery, but it's hit and miss, isn't it? And it has such a slow life cycle. That's what slows everything down, because in the nature of what we're dealing with. So there's no quick answer, unfortunately.
And Jeff, probably just a quick one. International audience, obviously, and we've got the climate assessment tool. How easy is it to kind of apply your model more generally? Is that doable? I mean, it's not packaged as a tool, but is that a plan for the future?
Yeah. Hopefully, once I've published it, I don't want to let too much go before I publish it. But yeah, but yeah, no. So what I've built in, it can be you can just put locate a city in and a country, and it will run the model. So I've got 54,000 different species of tree in there. So I've got tropic stuff as well, but also I've got as you see, over 55,000 cities. So yeah, it can be it's literally you put in your location and it will run the model.
Yeah. Okay. And then just lastly, just shifting away, because I'm sort of interested in this question as well. Katie Wagner has said, but she's curious about the management practices that attempt to increase organic matter in a sandy soil around the root mass. Obviously, at Kew, you've got sandy soils, and dealing with drought, part of it is the species, part of it is actually kind of that cultural practice. And I think she's interested in, well, what are those cultural practices, those management practices? Because turf is obviously quite a long way away from what the typical understory of the tree's native environments might look like. So are you doing anything to kind of increase the organic matter of the soils? What are you doing in that regard?
Yeah, so we've always done a lot of work from Kew, and this stems back from, you know, October of 80s, you know, the big October storm in the 80s. And we've learned over time that we have to manage our soils. So we do a lot of work adding organic matter we do several different methods. Ideally, I would just use an air spade and till the soil over just in the top layers and increase the organic matter. So we form our own mulch here. We all the wood chip from all the trees that my team prune have all go through the yard. We add in horse manure to increase more nutrients, a bit more green matter, and we turn it over until it's usable. And then we add that in. But that's just one solution. What we have done in recent years, which we've had very good results with, is using geo-inject, which is essentially a pneumatic pin that we bang into the ground, lets shots of air out, and then we've been backfilling with biochar. Now that's been very good. We're using not biochar for the sales pitch that we get for it all, but it's mainly for available pore space and just to hold and lock the water and nutrients in that soil, so we can slow that filtration down. So that's all we try to do, is try and add organic matter just to slow down the filtration through the soil. And that's the best way we found to do it. And on our really important trees you see on the slide with the castanifolia, that we put fencing around, and that's really important for some of the trees, especially the heritage trees, that we fence them off and manage that. So if deadwood falls, we leave it there, and when the leaves fall, we blow them onto the pits as well, and we leave them. It's a bit of a tough one with gardeners. They like everything to look nice and tidy, but we try to keep all that in there because that's what the tree needs. That's its own fertilization. It can adapt the soil conditions. So that's what we try to do where possible.
Oh, Jamie, you got your hand up.
I wanted to, before everyone leaves, there was one question, Andy, for you. How do people sign up for the area newsletter if they're interested?
Yeah, well, they sign up to area actually when they renew their ISA membership. The easiest option is to click the option to become a member of area, and then they'll automatically get all of our literature and information. Or they can email me, and I can, if they're not an ISA member, and then I can sort of direct them. But that's probably the best thing to do. Shall I put my email in the chat quickly?
And to answer some questions, there's no CEU code. We will be monitoring attendance based on the Zoom attendance report. Great.
I'm just going to pop my email there. It's not the area email, but I'm current president, so I should be able to sort of direct you in that regards. Please do feel free to email me. Is there anything else from you, Jamie?
No, thank you, Kevin and Andy.
Thanks, Kevin. I'll let you get back to your evening. And
Thank you very much.
We'll be in touch. Thanks, Jamie.
Speak soon.
Bye-bye.
Take care. Bye.